All right, it is 10:10. Good morning, everybody. Happy Monday morning. Hope you guys had a good weekend. It is good that you guys. It's good to see that you guys are here. We're gonna be doing more transformations today, so we're gonna be going into rotations. So again, it's just gonna be a little introduction, and we're gonna do the best we can with not having graph paper. Okay. So, as always, as we go through this, if you guys have questions or comments or concerns, make sure to use chat or to use your microphone, okay? And you can ask any question at any time. And because remember, this is about you guys, not about me. So, make sure you're asking lots of questions, especially if you're stuck or confused, because I want to make sure you guys can get this, okay? So, again, today we're going to be doing rotations. It's another transformation that we'll be looking at, okay? But before we go into rotations, let's go over this warm-up that goes over what we learned last class in case you guys have questions still about that. Okay, so in going over this, so this first one says I'm going to reflect. And it's frozen, so give me just a second. So this first one, I'm going to take a look at reflecting this triangle ABC over y equals x. So it's important to remember that from last class, that diagonal reflections are done with an equation because we don't have graph paper. So normally with graph paper, we'd be able to do this all on graph paper, but since we don't, we're going to be using equations. So the equation for this from last time, and remember, you guys should have this in your notes from last time, so you can just always look it up. So I have every point A, B, and what's going to happen is I'm going to switch A and B, right? So notice how my x before was my A, now my x is my y, right? And that's what it means. It's that y literally equals x and x equals y. So they switch. So when I go to do this reflection, I'm going to take a look at my original point. So my original point here, we can take a look, is I have my x and my y. So my original x was 1 and my original y was 3. And so I'm going to switch those. And so I'm going to have 3, 1. Okay. So for a reflection over y equals x with this formula, it makes it so we don't have to use graph paper and we can do this like that. Okay. So then for b, it's for my original xy was 4, 1. I'm going to switch those. So it's going to be 1, 4. And then for my c, my original xy is 1, 1. And when we flip those, we really can't see a difference, can we? Because it's the same number. And the reason for that is because 1, 1 is on the line y equals x because 1 equals 1. So remember how we talked about the distance from the mirror to the image is the same as the distance from the mirror to the pre-image. So if it's on the mirror, the distance is 0. It doesn't go anywhere. It's the same location. And that's what's going on right there. Okay. So again, we had those equations from last time. Okay. Going on to this one. So this one is a composite, right? So this is a composite transformation. Okay, so in a composite, we're going to have multiple steps. So what I'm going to do is I'm going to take my original points here, and I'm going to plug them in here. So we're going to get an A prime. Now when I do my A prime, what I'm going to do here is I'm going to take my x and my y of my original A, and I'm going to plug them into this formula on the right side. And that's what this is saying. It's saying every point, so A, B, and C, such that, and then I'm going to take the x value minus 4, and I'm going to keep the y value the same. So the x value is 1, so 1 minus 4 is negative 3. And then I'm going to keep the y value the same, so that's going to be at 3. Okay, and that's all we're doing. So then I go ahead and I get b prime. So I'm going to take my old b, I'm going to take my x, and I'm going to plug it in. So 4 minus 4 is 0, so that's my new x, and then the y is going to stay the same. Okay, and then I'm going to get my c prime. So my c prime, I'm going to go 1 minus 4, that's negative 3, and I'm going to keep my y. Okay, so what I did to triangle ABC is I moved it left 4, right? So this is just a way of saying left 4, and I didn't do anything in the y direction, so I just moved everything left 4. So I took my black points, my original points, I plugged them into this formula, and I get my new points. And again, we're doing this without graphing because we don't all have graph paper. Okay, so now what's really important with composite, I'm not going to go back to my original. I'm going to build off of it. So I'm going to take this new prime shape and I'm going to make my second prime. So I'm going to have a double prime. Okay, so I'm going to take this old point and I'm going to reflect it over the x-axis. Now I could sketch this out, but we also last class we went over a formula. So it's every point AB such that my A becomes negative and my B stays the same. Okay, so this is a reflection over the x-axis. Okay, so my A double prime, I'm going to take my x value and I'm going to change the sign. So the opposite of negative is positive and the y is going to stay the same. And then for B double prime, I'm going to have, I change the sign. Well, it's 0, so we can't really change the sign of 0. So that's just going to change, be 0, and then 1. And then I have C double prime, and then that's going to be 3, 1. Okay. And also remember that if we're reflecting over the x-axis, if x is 0, it's on the x-axis. Kind of cool, right? So, actually that's 0, 1. It's not on the x-axis. Is this the right formula? I don't have these memorized, so I'm going to look that up really quickly. I feel like that's what you would do for the y-axis. Uh-oh. I'm going to look it up really quick, guys. I feel like that equation might be wrong. So let's go here. What section is this? 4.3? No, 4.2. Yep. So I'm just going to go like this, and I meant to write this is the y-axis, and then that fixes everything. So if you guys can go ahead and fix that, that's the equation for the y-axis. It didn't look right, and it wasn't. So that's the equation for the y-axis. So just go ahead and change that, and then this is correct. Okay, like that. I should have had my notes out, right? But I also just wanted to remind you that I don't memorize this stuff, and you don't need to either. It's in your notes. Please use it. Remember that all of your homework is open notes, and yeah, so you're good to go there, okay? No one has really talked to me yet today this morning, so I just want to make sure you guys doing okay. Are we okay with this? And do you need any help? That is wonderful. Okay, and again, if anybody has questions, just go ahead and type in chat or turn on your mic like that, and that will work perfectly. Okay? All right, so this was reflections, and today what we're going to be doing is we're going to be doing rotations. So this is 4.3, and we're doing rotations. All right, like that. So rotations, there are 3 key pieces to rotations that we're going to be talking about today. And because we're in COVID times and we're doing online, we're going to make things really easy. So look at this calculator. If I'm going to rotate this calculator, what I'm doing is, right, I have a direction that I'm rotating in. I have an amount that I'm rotating, and I have a center, right? So I can rotate it from the bottom, and that's one type of rotation, where I keep the bottom in the same location. Or I could rotate it, here, maybe if I go like this, and you guys can see me. If I rotate it, let's say I rotate it about my elbow. You guys see how that's a different rotation? Okay, so my elbow is rotating, versus if I rotate it about the calculator. Okay, so where I rotate it about can be really important there as well. So let's write those all down. So for our class, we're going to simplify things. So we're not going to look at all rotations. We're just going to look at rotations that are basic so that we have a good introduction. Okay, so the first one is going to be the center of rotation. Oops, that's an O. The center of rotation, okay, is what you're rotating about. So for us, all of our rotations are going to be about the origin. So about the origin, and your book is going to use the word origin, and hopefully you guys remember origin just means the point 0, 0. Okay, so that's the center of your coordinate system. Okay, so for our purposes for this class, all of our rotations are going to be about the origin. Okay, it's going to make things really simple and straightforward for us. So going forward, let's remember that. All of our rotations are going to be about the origin. Next, we need to know about the angle of rotation. Okay, so the center of rotation, so the angle of rotation is the amount that we rotate. So degrees for right now, how we measure rotations is degrees. So for example, if I'm looking straight ahead and then I turn my head, I rotated my head a certain amount of degrees, right? So if 0 was me facing forward and I go like this, then I'm rotating a certain amount from 0. Okay, so that's our degrees. Now, for us to make things easy, we're only going to do 3 types of rotations. We're going to do 90 degrees, 180 degrees, and 270 degrees. Now, we're not going to do 360 because 360 is you're just facing the same direction that you were originally. One thing you should note, though, 90, 180, and 270 are all multiples of 90. So 90, there's one of them. 90 plus 90 is 180, and 180 plus 90 is 270. So these are all rotations of 90. Now, that used to be a big deal because we used graph paper to do that, and graph paper has 90-degree angles on it, but we're not using graphing paper this year. So you can just think of them as these are easy to do if we had graph paper. Okay. Next, we need to have a direction. Right? We need to have a direction of rotation. So there are 2 ways, there are 2 directions when we're talking about rotation. It is either clockwise or counterclockwise. And the word clockwise comes from analog clocks, because you guys might have grown up in a house that doesn't have any analog clocks, right? So when I say, so what we're going to be doing is we're just going to pick one because it's COVID and we don't have a lot of time, so we're going to make it nice and easy. So we're going to pick the way that's going to show up next trimester, and that is counterclockwise. It turns out that counterclockwise is really important in mathematics. So counterclockwise is this direction. And you can't say left or right because on the top it's going left, on the bottom it's going right. Okay, so counterclockwise is like this. Okay, so this is super important. Make sure you guys have this down in your notes. For our class this year, the center of rotation is always going to be at 0, 0. The angle of rotation, we're only going to do 3 types of rotations, 90, 180, 270. And our rotation, our direction is always going to be counterclockwise. So you'll see in your homework, it won't tell you the direction. It won't tell you, sometimes it tells you the center. But you can always just assume that the center will be at 0, 0. You're going to only do one of these 3, and the direction will always be counterclockwise. Okay? So this next part, I just want to put this in here. So for this year only, right? So if you have a sibling that wants to use your notes next year, this won't be helpful for them. Okay. So for this year only, we don't have graph paper. So if we had graph paper, now like the homework assignment will have graph paper on it, and if you take a state test, that will have graph paper on it. But we don't have access to graph paper. So I used to teach a method of rotation that's called the claw, where you take your finger and then you rotate your finger, and then you just map it onto the diagram. We can't do that this year. So for this year only, I'm just going to show you guys rotation formulas. Now, you're like, well, why don't you normally teach rotation formulas? Because, guys, these rotation formulas are really not useful. Because these rotation formulas only work if you're rotating about the origin, only if you're doing these 3 angles, and only if you're going counterclockwise. Okay? So they're so specific that you'll probably never use these again. Now, you're going to be like, oh, there it goes, math, it's pointless. No, no, no. The whole idea, guys, is, and this is the important part, the skill that you're going to use the rest of your life, can you, right, have a set of formulas? Can you know when to use them? Can you look it up, right? Because most likely, if you work in a job that uses math, like formulas and stuff, you're going to have to be like, oh, it's this situation. I need to use this formula. Can you do it, right? And then if you can do that, you're going to be good to go. So again, make sure you take good notes here. You're going to be fine. You're going to be able to do this. Okay, so again, these only work for the above conditions. So our formulas are this. For a 90-degree rotation, about 0, 0, counterclockwise, you're going to take every point AB such that you're going to get negative BA. That is, you're going to switch A and B, and then the B becomes negative. Or you can think of it as the opposite sign. So if B was positive, it's now negative. Or if B was negative, now it will be positive. Because you can think of the negative as opposite. It's the opposite of positive. 180 degrees is you take point AB such that, and then you're going to have negative A, negative B. Now, to me, this is the one equation that makes sense. If you're walking down the hallway and you turn a 180, you're going the opposite direction. So take a look. If we have an initial point AB, notice how all we did was we took the opposite of A and B. Okay? So for me, 180 is one that I do just kind of have, not necessarily memorized, but it's just kind of like common sense, right? If 180 means to go the opposite direction, then it's the opposite points. So again, I wouldn't memorize any of these. I just think that this one's easy to kind of remember. And then 270 degrees, I'm going to take every point AB such that I'm going to switch, but now the A is opposite. Okay? So again, you just want these somewhere in your notes. And just like we did with the reflection equations, you're just going to want these somewhere in your notes, because remember, when you're doing your homework, it's open notes, and when we have our final coming up, it's going to be open notes as well. Okay? So just have that easy to get to, and then this will be a breeze. And again, it's just going to be an intro. So it's just going to be like you're hired for a job, and it's going to be like, hey, if you have to do this formula, do it, done. Okay? So we don't have to do too much work or too much thinking there. Okay? So what we're going to do today is we're just going to practice using these formulas and do that. And again, I apologize. I know this is kind of boring, but it is what it is. And I'm just trying to get you guys the best at what we can do online. Okay? And so, in a sense, it's easier than what we'd be doing, right? So, hallelujah, right? Who's down for something easier? I'm down for something easier. Let's do it, guys. So, let's do this example together. And then the next 2 examples, I'm going to have you guys practice on your own. So, we'll do this example together. And then that way you guys can feel a little bit more confident with what we're doing. So let's say I have, I'm going to have a four-sided object. So I'm going to have R is 3, 1. And then I'm going to have S, and S is going to be 5, 1. And then I'm going to have T, delicious T. And I'm going to have 5, negative 3. And then I'm going to have U, which is 2, negative 1. Okay, so those are my points. And what we're going to do, now this used to be a lot of work doing it by hand. And the reason, now, you might be like, well, crap, why don't you teach, I guess I already talked about that, why I don't teach formulas? Because it only works for very specific ones, and let's be real, you're never going to memorize that because it's just so not worth your time. And so I teach a way that works for all rotations all the time, and it doesn't take any memorization. So I'm sad that I can't teach that to you guys this year. I'm really kind of sad about that. So what we're going to do is we're going to rotate RSTU 270 degrees about the origin. Now, why your book says about the origin, I'm not sure, because for what our purpose is, everything is going to be about the origin. Okay. So we're going to rotate 270 degrees about the origin. So the first thing I'm going to do is I'm going to look up my equation. Right? So we just looked up our formula, and our formula said, okay, we're going to take all our points, A, B, and what we're going to do is we're going to switch them, and the A becomes the opposite of what it was before. Okay. So now we're going to just practice applying this to this. Okay. So I'm going to have R prime. So what does it do? It switches A and B. So I'm going to switch 3 and 1. But the previous A is going to change sign. So I'm going to switch the 1 and the 3. But the previous A is going to change sign. So 3 was positive. Now it's negative. Okay, so that's how that formula works. I switched A and B, and the old A is now negative. And you guys can stop me at any time and ask and let me know if you have questions. So I'm going to do S prime. So I'm going to switch these. My A term is 5. So when I switch the 5, I'm going to change the sign. So now it's going to be negative 5. And then I have T prime is going to be negative 3, negative 5. And I'm going to have U prime. That's going to be negative 1, negative 2. Okay. So again, easier in the sense that we have formulas for this, but these are very specific things, right? So it's about the origin, and we're going counterclockwise. Okay. So we're not learning how to do any rotation. We're just learning how to do these specific rotations. And I would argue we're not really learning either. We're just learning how to use a formula, which is a valuable skill because a lot of you guys, when you go out to work, will be given formulas that you'll have to use, right? For example, doing your taxes. Okay. All right. So the two problems that you guys, there's there any questions? I haven't really heard from you guys. You guys doing okay? Is there anything you guys want to ask? Any questions? It's very unlikely that I have a class of 33 without questions. Well, I appreciate you giving me feedback. Thank you. Yeah, right. No, I understand that the weather is pretty crazy and super windy. So, and remember, guys, if the internet does go out, I post all of these lessons to YouTube. So once you do get internet back, that you guys can go back over these, and then you can always let me know if you have questions. All right. So let's. You guys are going to try this one on your own. So to do this, we're going to do a composite. We're going to compile everything together. So let's do some composite transformations. Remember, composite means 2 or more. Oops, I should do an S on that. Transformations, plural. Okay, so to do this, we're just going to do this with segments because less points, right? It's just busy work if you have more points. So we're going to look at segment AB, and A is going to be at 1, negative 3. And B is going to be at 2, negative 6. Okay. So it's a composite transformation, so we're going to have 2 steps, right? So my first one is going to be, we're going to reflect over the y-axis. And then B, we're going to rotate 90 degrees about the origin. And I'm writing about the origin because that's what your book says. Okay, so remember, you have to go in order, and each one is going to have their own markings, right? So this one's going to be A prime, B prime, and then this one down here is going to be A double prime and B double prime. Okay, so these ones require two formulas. So you're going to have to look in your notes for the formulas, and I would write the formulas right next to them so you know what you're looking at, and then get the formulas and then do the conversion. So this is a practice of doing a reflection formula and a rotation formula. So I'm not going to give you guys 3 minutes to do this. What page? Well, it's multiple pages out of the book. This is why we're taking notes. So for the reflections, it's page 183 in the book. And for rotations, it's page 191. But again, since they're on two separate pages, I would recommend having them in your notes. So again, rotations is on 191 and reflections is on page 183, right? 4.2 and 4.3. So you guys can have 2 minutes to work on this and get that done. All right, so hopefully you guys are finding success with this, right? So we're looking up the equation and then we're doing that. And you can tell that we make mistakes because obviously I made a mistake on the warm-up, right? So there's that, right? So, but I don't know if you guys caught it or anything because no one said anything. So, all right, so reflect over the y-axis. So if I look that up, so reflect over the y-axis is I take every point A, B, and I'm reflecting over the y-axis, so I got to think about that because I don't have this memorized. It's straight up. So that should mean if I'm reflecting over the y-axis that my x is changing and my b is staying the same, like that. Okay. And then for a 90-degree rotation, we just looked that up. So that was, if I take every point AB, that I'm going to take that, and then I'm going to double check what's up. Okay, so if I take a look, so we got to be careful here. I really hope I didn't write this down in our notes wrong. So the y-axis is negative AB. So if I made a mistake, I'm terribly sorry, but we're correcting it now. But yeah, the y-axis is negative AB. And the reason for that is if you're reflecting over the y-axis, right, you're going left to right. So the x is changing, but the y is staying the same. Oop, I zoomed in really far. So if we wrote that down, then that's a mistake, and we gotta fix that because that was an error. So let's make sure we have that right. I'm not saying that's your fault. It could definitely be my fault because heck, I make mistakes, but hopefully not. So let's see here, AB. So if I'm doing this with rotations, and I'm doing a 90-degree rotation, then I'm gonna have negative BA, like that. Yeah, we hope we didn't make a mistake. That would suck. Sorry if we made a mistake. I'm not trying to make mistakes. They just happen. So let's take here. So I'm gonna take these red points and I'm gonna plug it in for these black points. So I'm gonna take my first ones and it looks like I'm keeping them in the same order, but I'm just changing this one to negative. So this would be -1, -3. And then I'm taking this, they keep them in the order, and I'm just changing the first one to negative. Okay. And then I'm taking these black ones, and I'm going to this blue one. So I'm taking the points, I'm switching them, and then the original B becomes the opposite. So the original B becomes the opposite, and I'm switching them. The original B becomes the opposite, and I'm switching them. Like that. So this would be my final answer. Check my original notes, not for reflections. So yeah, this is what I have for my notes. So so that's what I took. So the y-axis, right? Yep, that's incorrect. Silly. So I made a mistake there. So I apologize for that. Feels really embarrassing, but at least we'll get moving forward from there. Does anybody have questions about this? Yep. Sure, let's do this. So if we reflect over the y-axis, then you're going to go from AB. Now, if you're reflecting over the y-axis, right, you're going left to right. So if you go left to right, your x changes, but your y doesn't. So that is going to be -AB. And then if you reflect over the x-axis, you take every point AB, and then you go, your x's stay the same, but your y's, that's a -B. So you're, yeah. Oh no, yeah, I don't want you to get that wrong on the homework too. I'm really sorry about that. As you can see, I've never taught those formulas before in my entire life. So there you go. That's them. Because I mean, as a math teacher, I never use those ever. So, but you guys are using them because we don't have graph paper, and so it's easier to do it this way. So you'll be fine, for sure. Thank you for pointing it out. By the way, that's what happens when no one says anything. Is that my mistakes go unchecked? Thank you for that. All right, so let's do one more. So it seems like no one else has questions about this. which is a little strange. But you guys all got this 100%. No one's asking any questions. All right. So let's do another example. So our example here. So it doesn't seem like people are participating. So I'm going to call this triangle TRY. So T is going to be at -3, 2. And R is going to be at 0, 4. And Y is going to be at 2, -3. So that is triangle try. And this is going to be a composition. So I'm going to ask that you rotate 180 degrees about the origin. Okay, and then B, you're going to reflect over the x-axis, and then C, ooh, 3 transformations. You're going to take every point x, y such that x minus 2, y plus 3. Okay, so this one has 3 parts to it. Okay, so that means you're going to have a t prime, r prime, y prime. You're going to have a t double prime, r double prime, y double prime. And you're going to have a t triple prime, r triple prime, y triple prime. So you're going to have 3 different points because you're doing 3 different transformations. Okay, so let's reset this. I can give you guys a little bit more time here. I can give you 2.5. But this should go pretty quick since we are just using formulas. So there you go. And as always, if you guys get stuck or have questions, please let me know. All right, hopefully that was enough time. Did you guys have enough time to do that? Well, here, I'm going to go through one by one because I'm not going to lie to you. I don't have the final answer yet. right? Because I haven't done this yet, so I'm going to do it with you guys. So let's go ahead and do this. So the first thing I'm going to do is I'm going to go ahead and I'm going to take this red one and I'm going to plug it into here. So let's see here. I'm going to rotate 180 degrees. So my formula for this is I'm going to take every point A, B, and I'm going to do the opposite. So I'm going to have negative A, negative B. So I'm going to have T prime. So the opposite of negative 3 is positive 3. And the opposite of positive 2 is negative 2. And then R prime, 0 doesn't really have an opposite. It's a special number, so it just stays, right? Nothing is, the opposite of nothing is something, but that's not what we're doing. We're just doing opposite signs, so it's nothing. So I have negative 4, and then I have Y prime is negative 2, positive 3. Okay. So that's what I did for my first one, right? So I'm just taking all my points, and I'm taking the opposite sign of them. 0 doesn't have a sign, so it's still just 0. Then I'm going to take these points, and then I'm going to reflect them. Okay, so I'm going to have T double prime, and my equation for reflection over the x-axis is I'm going to take all my points A, B, and then let me think about this because I tried to memorize it and I made a mistake. So if I'm reflecting over the x-axis, see how I'm going up and down, right? So I'm going over the x-axis, so my y changes, so my A stays the same, my y changes. So my y is going to change sign. So I'm going to keep, so I'm going, look, I'm not going back to my original. I'm going to my T prime. So I'm going to have the 3 stays the same. The y changes sign. I'm going to have R double prime. My x stays the same. My y changes sign. And then my x stays the same. My y changes sign. Okay. And then we're getting to that final answer piece, right? So I ran out of color, so I'm going to do red for my last answer. So I'm going to take that blue one, and I'm going to do this last one. And the formula is right here, right? So I'm going to take all my x's, I'm going to subtract 2. I'm going to take all my y's, I'm going to add 3. So this is T triple prime. So T triple prime, so 3 minus 2 is 1. And then 2 plus 3 is 5. So that's my first one. So 1, 5. And then I have R triple prime. So I'm going to have 0 minus 2 is negative 2. And then 4 plus 3 is 7. And then my last one is Y triple prime. So I'm going to have negative 2 minus 2, that's negative 4. And negative 3 plus 3, that's 0. So that's my final resting place for triangle TRY. Okay, so with that said, it looks like the couple of answers I got in chat look correct. So that's really good. Does anybody else have any questions or concerns? Okay. Well, we do have about 6 minutes left. I'm going to use this time to talk to you guys because we got some serious issues that we need to talk about as a class. So first of all, I want you guys to know that March 12th is the last day of this trimester. There is no school March 12th. Okay, so what that means, if we look at a calendar, right, that means that we have this week and 2 more weeks afterwards, but it's not a full 2 weeks. So it's more like this week, next week, and half a week. So a lot of you guys have 1 or more missing assignments. If you guys have missing assignments, remember that your grade is worth 80% of your grade. Okay, so we need to be getting assignments done. So what's really, and yep, I get it. You can take off when you need to. Thank you for letting me know. So what's gonna, and I'll answer that question in just a second. So what's really important is that you guys have to get your assignments done. So make sure you log into Skyward and you check Skyward. Check Skyward to see what assignments you're missing from my class. If you're like, hey, it says I'm missing this, but I turned this in, then you should send me an email and say, hey, I'm in your second period class and I turned in this assignment. It's just not showing it up on Skyward. So then I can check into it, and because Big Ideas does not tell me when you turn in late work. So you have to tell me when you turn in late work. If you turn in an assignment late, please send me an email saying, hey, I'm in second period, I turned in this assignment. And then I can update Skyward. And I usually update Skyward pretty quickly if you send me an email, okay? So please make sure that you guys are turning in work. If you turn in work late, send me an email so that I know to update Skyward, okay? And then getting to the next question. So some of you are saying, hey, advisory said that we might go back to school third trimester. So I just want to warn people that the district put out a date, and that's not a date that's probably going to happen. So if you do go back, we don't know when. And I want you guys to know, if we do go back, it's not going to be anything remotely normal. So if we do go back, all it's going to be is like, you're just going to be in a classroom at school. You're going to be 6 feet apart. You're going to be wearing masks, and there's going to be an adult in front of the room. And it's not necessarily going to be me. It's just going to be some teacher. And you're going to be sitting in front of your Chromebook, and you're going to be in class. Like, does that make sense? So like, you're going to be at school, but all of your lessons are still going to be online. So I just want people, when we don't know when. We don't know when. There is no when. So the district put out a tentative date, but that's probably not going to happen. So the thing is that they're trying to come back. It's probably going to be sometime during the middle of the last trimester. But I just want you guys to know, I think there's a lot of misconceptions about what going back to school will look like. It's still going to, we can't have you go to all your classes. So you're just going to be in one classroom, and you're going to be 6 feet apart from everyone. You're going to be we're all going to be wearing masks. I'm going to be wearing a mask, and you're going to be on your Chromebooks, and you're going to be doing your lessons from school on your Chromebooks. And that's what's going to happen. So it's really not all that exciting or anything worth looking forward to. It's kind of silly, actually, that we're doing it. So I just want to give people a heads up on that. And so there is no when. So they have to, like, there's a whole bunch of things they have to figure out, like, how are kids going to get to school? How are kids going to get home? How are kids going to eat? Old Main right now is under construction, so what room you're going to be in, and then safety protocols, like how are we going to make sure every kid gets a mask, ventilation, right? Like, if the only way to ventilate is open windows, then it's going to be really cold in the building. So there's lots of things to work out. So it's not going to happen right away. Okay. But yeah, just when people say we're going back to school, I don't want you guys to think that, like, oh, I get to hang out with my friends again. Like, you're going to be in a room, and you're not going to move rooms. You're just going to be in one room the whole day, and then you'll go home. So it's not normal. Does anybody else have any other questions about that? So what did we talk about? One, you guys have to get your practice done, right? 80% of your grade is your practice. Get it done. We only have about 2 weeks left. Okay? So get your homework done. If you need help, my office hours are in the morning from 6:35 to 8:50. You can make an appointment, or you don't have to. You can just show up. But I can sit down with you, and I could do your homework with you, right? I could bring up the assignment onto my screen, and we can talk about it and do that. Okay? Please, please, please get that done, guys. We need to get you guys through geometry and onto your next class, so that next year you can start and we don't have to retake a class. Okay? So please make sure you guys are getting your assignments done. If you have questions, email me or come to my office hours. Does anybody else have any general questions or comments that they want to share? All right. So I'm going to go ahead and